I do remember we have done this. If a piston is non-conducting, we did problem. Now I am bringing a conducting one. Read the question carefully. Little bit, okay, a good question, no? So what we are doing is the extra agent will slowly, the piston is slowly displaced by an extra agent. Find the temperature of gas when the volume of greater section is 7 times the volume of smaller section. I'm going to displace this piston. The volume of cylinder will remain same. It will not change. Okay, let me bring the now the container. Okay, now the piston got displaced here. Okay, meanwhile, I am setting the diagram. So who will displace it slowly? The extra agent, and it's a conducting. This is the primary part. If it's a non-conducting, I think check my notes, it's available. If you want, I'll discuss that also along with this. So that conducting, non-conducting. In a container, if you slowly moved by extra agent, find the temperature of gas when the volume of greater section is asking something to temperature there. I think I discussed in the class, it was about the work done by extra agent to displace it. Okay, this volume, let it be V1, V2. Temperature has to remain same. Why? And it is being displaced by distance x. By whom? By an extra agent. So here the force will be pressure force P1A, here P2A. So what is the work done by extra agent? Slowly, the extra agent will displace it slowly. From rest to rest, it will be moved. The piston, it will be moved from here I'll show this. It will be moved from rest to rest, rest to rest, rest to rest in this way. Oh, unnecessary trouble. I invited, it seems. Yeah. No, let's get into this one. Don't try to write equation. Here, this problem is a little bit dangerous. Definitely, the problem is there from E domain. Some mass will be there. Keep this in mind. First, we'll calculate what is the pressure. What are the volumes we can write? Whatever the volumes we'll write. V1 equal to V1 equal to 7 times of initial. When the volume of greater section is 7 times the volume of smaller section. So V1 should be 7 times of V2. What is V1? V0 plus AX. What is V2? V0 minus AX. This is the one thing. So let's add up this. And what is V1 plus V2 should be equal to V0. I think this equation is of no use, I feel. Instead, better bring in terms of that one. So V1 equal to 7V2. V1 equal to bring this. I think this may help us a lot. So what is V2 is equal to V0 by 4. V2 equal to V0 by 4 means V1 will be 7 V0 by 4. This will substitute, we'll get the expression for X. AX will get it. What is AX will be 7 V0 by 4 equal to V0 plus AX. Three V0 by 4. This is what the change in volume. I'll be using it. Call this is V. Call this as V. We'll use some symbol. As X varies, the V also will vary. What we can do now? Work done, will calculate. So now tell me, like, what actually happens? What are the process we have to bring here? There's a primary question is what I should ask a student being a teacher. Anybody put in chat? You can put in chat box also. What process the gas will primarily will undergo in each part? Adiabatic, isothermal it is. Temperature of the gas remains constant. Find the temperature of gas. Find the temperature of gas when the volume of greater section is 7 times the volume. Okay, somebody said isothermal, somebody said adiabatic. Can it be adiabatic? First of all, adiabatic not possible, no, because there's a heat flow from one part to other part. There's a ruled out. Can it be isochoric? Volume is changing in both the parts. Next, okay, that isochoric, volume is changing. What about the pressure? Pressure also varying. You see earlier P0, I wrote P1. So it cannot be isothermal. It cannot be isochoric. It cannot be isobar. What about isothermal? Isobar, not possible. Isochoric, not possible. Adiabatic, not possible because there's a heat exchange. What is left over? Isothermal. What about isothermal? Will it be isothermal? In isothermal process, what conditions will come? The question itself is telling that find the temperature of the gas. Means earlier it was 300. Now it will become some other temperature. That's why I wrote in the expression T. So therefore, what process the gas will undergo in both the parts? It will undergo general thermodynamic process. This is something very important. So if you, I think sir, why means is asking the temperature. Himself is telling the question that temperature is going to change. Finish over. General thermodynamic process, what you're going to do? Basic formulas will apply it. The basic necessity formulas we have, we are going to apply that and we are going to work out. So, but altogether, work them by exchangent, what will happen? The exchangent will display this piston. Already I shown the moment of piston slowly from rest to rest. Where do that energy go on? Convert into rise in intensity of the gas. That's all. Then, sir, like, what about the this one work done by the gas? If the gas does work, because of work done by the gas only, there'll be change in intensity. But there'll be flow of energy. That's why it's not adiabatic. So work done by exchangent, what you write? Just like plus delta U. Work done by gas will be minus delta U. Work done by exchangent should be just plus delta U. I did work, there's a change in intensity. So mechanical energy get converted into rise in intensity of the gas in the both the parts. That is the condition. So I think now things will become a little bit complicated. What is the thing is like, as I'm moving, what is the state of pressure? Will it be remain P naught only? No, it's going to change. Temperature of gas changes, volume changes, pressure changes, temperature changes. So therefore, what is the requirement now? So better to this. That's why I just brought X. So let's express everything in terms of X, then we'll try to integrate. Let's bring everything in terms of X, then we'll try to integrate. And now first we'll calculate the pressure P1. Pressure P1. P1 equal to V naught plus AX. PV equal to nRT. Number of moles in same, it can move inside a closed terminal cylinder at gas at equilibrium. Piston divides into two equal parts. So initially, I think number of moles, let it be N. I need not to bother that. And the temperature is T naught. This initial temperature we'll call T naught. Okay, this will be temperature. Shall I write T naught or any other thing? At any distance x we are writing. So look at this one here. Here I wrote equation P1 V naught plus AX is equal to, or if you want for your convenient, I'll write the PV1 P1 V1 equal to nRT. P1 V1 is V naught plus AX equal to nRT. Keep this. I think this is going to really help us a lot. Then what about P2? P2 V2 equal to nRT. P2 we don't know, but V2 is V naught minus AX. Now, what is work done by the extra agent? He has to overcome this difference in pressure forces, no? He has to overcome the difference in the pressure forces. So therefore, work done by extra agent dW should be equal to P1A minus P2A into dx. So P1 minus P2, we have equations, we'll substitute them. nRT V naught plus AX, nRT V naught minus AX. Again, this will be dx. nRT, I'll take outside, V naught minus AX. This will be V naught plus AX. All divided by V naught square minus AX whole square. Minus AX plus AX, so this will become 2 nRT V naught by V naught square minus AX square into dx. V naught will cancel. Okay. V naught will cancel. So this will become 2AX dx. I made changes. So AX is we represented V. So let it be equal to V. So this will become 2 nRT V A dx. First, I'll calculate the pressure difference. We have to bring expression for dx, no? Okay, let it be here. Okay, AX is what? I'll write it V. I'll slide up. I need some space. So 2 nRT. AX is what we represented V. So V naught square minus V square. This is dx. Dx, what pen we can write V by A. dV by A, we can write it. We can adjust. What this extra agent, because of this, there'll be change in intensity. So what is change in intensity is equal to NCV dt. So, okay, I think this is a very important part we have come here. So now let me simplify. Next part, I'll go for it. Okay, look at this one. Now from here. So this work done, change in intensity du should be equal to, what is the type of gas? It's a monoatomic gas. Ideal gas, gamma equal to 5/3. We have gamma also. Okay, so yeah, sorry. Now we'll proceed here, gamma equal to. So how to get the change in intensity? So shall we write 2 times or only 1 time? Change in intensity of gas. change in intensity of gas, it should be equal to du is equal to 2 times of number of moles. Okay, it is like a 3R by 2 gamma value, we know it. Okay, we'll do one thing, nR gamma minus 1 2 times into dt. This will be 2 nR. Gamma is 5 by 3. So 5 by 3 minus 1 into dt. So this will become 6 nR. Okay, I think only 3 nR by dt. Now what to do now? We have two set of equations. I think we are very near, just we have to integrate here. What to do? Two set of equations are there. What all X agent does work, where did it go? Convert into rising intensity. Sir, is it adiabatic process? Because no heat exchange, net heat, there'll be heat exchange between one part to other part. So therefore, here what we are going to do, work done by X agent is equal to du. The X agent did work, that it got converted into rising intensity of the system. So this will become now 2 nR dV V naught square V square into dx is equal to 3 nR dt. nR get cancels. So this will become 2t V dx V naught square V square equal to 3 dt. Let's integrate this. This will become, but we have dx, no? So shall we write change in volume as a into dx? So in place of dx, I'll write dv by a. So this will become 2 by a dv v dv v naught square equal to, we will bring everything like this here, by dt by t. Now what should be the limit? Initial temperature T naught to final temperature T. What should be the volume? 0 to 3 V naught by 4. Look at the limits once, the way I'm putting 0 to 3 V naught by 4. So solving this will get the expression for temperature. I think really little bit lengthy. Some integration is what we have. Solve this 395 Kelvin, what we get the answer. Sir, is it not adiabatic process? Because work done exchange equal delta U. If heat exchange, say like a overall, this is applied for total system, but individual, there's a exchange of heat between individual parts. So therefore, it cannot be adiabatic. What is this equation we wrote? Net work done. Net work done means for the total gas present in the cylinder, not for individual part. So based on that, you should not say adiabatic. So here, what is the condition we can put? Heat exchange occurs between the parts of a gas. So it cannot be adiabatic. Okay. This then Edo, I suggest you better have once going for exam, because there's all possibility of asking direct questions in Edo. That's what I feel. Have a look once. Well, I'll end up the, we'll try to wind up the class. Okay, this is about the, let me read question. A beam of gas molecule is incident normally on a plate AB. Each gas molecule has mass m and velocity v. The incident beam falls on area on the